Thank you very much, and I hope you don't have too high expectations. The main reason I wanted to present to you is not because I thought I have great results. The reason is very selfish. I want feedback from your collective wisdom and perhaps some ideas on how to include. But this is just a very small portion of a study, really the beginning of a study. More like a trial. Anyways, so blue notes are notes that are lowered for expressive purposes, and they are usually in blues or blues-derived genres, so jazz, blues, gospel. Usually it's the 3rd and the 7th scale degrees, sometimes also the 5th scale degrees. I will specifically focus on the 3rd scale degree here for the purpose of this very short presentation. By the way, it will be very short, and I will not take a lot of time. So the idea was, so just the background, my idea was, I'm not really a jazz musician or blues musician, but I've played some. But I'm fascinated with pitch deviations, and I once tried a project that I tried to do with Sonic Visualiser that focused actually on art music, on let's say if you have an G sharp and an A flat both in the same piece, and if you have an instrument that is, let's say, a non-fretted string instrument, whether the A sharp would be played higher than the G sharp would be played higher than the A flat or not. And that project was actually a failure because I used violin recordings, and they had too much rubato, and I could not really pin down those specific pitches. But for this project, I took a vocal recording and an a cappella blues recording. And so this is the blues. I got too much time for the crime I'd done. And yes, J.B. Smith was imprisoned for murder, and I think he had a 40-year sentence, and somebody went to prison and recorded him. And so this is the blues, and we'll just listen to the beginning, maybe to a little more than what you see notated here. Let me say something about the notation. I don't think I actually looked for a notated version of this blues. I transcribed it by ear initially. And so what you see here is my transcription sort of by ear. I may have made a correction or two after I analyzed it with Sonic Visualiser, but the initial transcription was by ear. But let's listen so we get an idea.
I got too much time for it. Oh man, for the crime I done. Well, if I had a notice, oh, I'd have broken run. Well, if a jazz had a notice, oh, boy, I'd have broken run. I got way too long, buddy, for the crime I done.
All right, so the blues is actually quite lengthy, but I focused just at the beginning as a case study. So
I got
no. So I wanted to specifically look at the 3rd scale degree. So this piece is in E, in the key of E. Of course, you could argue it's E major, or you could argue it's E minor. But I think of it as an E major. that has blue notes, and I wanted to focus on the third scale degree. But of course, with blue notes, you have lowered scale degrees. So you would have at least what I learned and what I had perceived listening. Then you had a lowered third scale degree. Now I'm a pianist originally. I mean, my first instrument was piano. And so I know that, of course, on the piano, you would just play it a half step lower if there is a blue note, right? But then the question is, but how exactly lower is it if it's not a tuned instrument or a fretted string instrument like the guitar, but maybe either unfretted or in this case, voice. So I looked at the third scale degree here. And I used Sonic Visualiser, and I have Sonic Visualiser open. I will go there in a minute too. So you can have different views. I had two panes open, and so the bottom one is really where I read off the pitches. So this is I think this is a peak frequency spectrogram, but so you can then hover your mouse over any portion of this melody, and then here it tells you exactly what the pitch is. At this point, it's G3 minus 20 cents. Oh, that's the bin pitch. Never mind. It's too small for my eyes, but there's a range between G3 minus 20 hertz and G sharp 3 minus 26 hertz. So there's a range, and I, of course, if a note is prolonged, I looked at sort of what the range is, so that I got the range of the frequency. But there are other ways to determine the pitch that I will show you in a minute. But let me show you first the results. And so whenever the melody goes up, the pitch usually is around G sharp. And sometimes it slides up to that. It may start lower, it slides up to that. But whenever the melody is descending, whenever it goes down, that's when we have those blue notes. And so the range of the frequency here is 187 to 192 hertz. And I use some online calculators that translate hertz into pitches just to see exactly. But so the most important finding is that it is not just lowered by a half step, but it's lowered more. So it should be a G sharp if it's like in major, but as a blue note, I thought it would be around G, but it was always lower. So it was usually between F sharp and G, the range in which the blue notes were whenever the melody has a tendency to go down, So here, even slightly lower than here. Here it's sliding down to 187 hertz. Here is the range 186 through 189. Here the melody goes up, so it slides up to 205 hertz, and here is the range. So the bottom line is, when the melody goes up, we do not have a blue note. When the melody goes down, we have the blue note, and the blue note is not just a half step lowered, but more than a half step. That is the main finding so far. This is how I summarized it here. Notes that are lowered and embellished for expressive purposes. The third is not lowered if the melody is ascending. The third is dramatically lowered when the melody is descending. The third, as a blue note, is lower than the lower third scale degree as found in a minor key. The fifth scale degree is only slightly lowered, but I haven't really focused on the fifth scale degree here for this initial study. So I wanted to show it before I finish in a little more detail. So I will actually go to Sonic Visualiser. As you know, there are different ways to look at this. And so you have the waveform here. And you can also overlay that, or you can add additional panes with a spectrogram or melodic range spectrogram, but I like using the peak frequency spectrogram. And then you have this view. And so you see, of course, there's only one note at a time, but there's an overtone series, and that's how you see this quite nicely. But to measure the frequency, hold on. Oh, that was too far. Oh, no. Let me redo this. So sometimes my computer takes a long time when I may want to make those adjustments. But anyways, so let's listen just a few seconds.
I got too much time for it.
So you can then hover your mouse over here, as I showed in the picture earlier, or here, and you see, yeah, actually the third scale degree here, it's going up, right? And that is very difficult to determine. That's one of the questions I have, and maybe some of you have great suggestions, where to exactly determine the pitch. But if it goes down, here's the third scale degree, and depending on where we are, it's modified, but it's anywhere between F sharp and G natural. So now there is another program that is in the Sonic Visualiser family. It's Tony, which is also on the Sonic Visualiser website. You can download that. And once you run the analysis, and so Tony is specifically for monophonic music, which this is obviously. And so if you run the analysis, it automatically puts these brackets around and analyzes pitch. So let's listen to this in Tony for just a few seconds.
I got too much time for it.
And then it does play those pitches. You can also not play it if you want to, but it plays those pitches that it analyzes it. Now, then you have a preconceived notion. The data that I showed earlier was actually that I read off in the peak frequency spectrogram in Sonic Visualiser. But this is quite interesting here too. So anyways, here is the third scale degree with 205 hertz. And here it is with 190 hertz. So here it is on the way up. Here it is on the way down. Here 189 hertz. So now this program here, I think, calculates an average within that portion that it had automatically detected. But essentially, the results are the same of what I read in the peak frequency spectrogram in Sonic Visualiser, that it's the blue notes, the third scale degrees, are dramatically lowered on the way down, but not on the way up. Or on the way up, it very often slides up. But that is my very brief presentation, and I hope we can have a more lengthy discussion. And so I'm specifically looking for ideas on what I could do better and possibly even more automate this process, because what would be interesting if you had large data from many different pieces to analyze, but the approach I've been using, it's very time consuming. So thank you for listening to me, and now I'm selfish and love to hear your suggestions.
Thank you, Nico, for this impulse. I'd like to ask Chris Canham, do you know how the Tony plugin or the Tony app actually works? Is it the same? Is it working with Matthias Mauch's Pigeon?
Yes. Mm-hmm. Yes, it uses the PN pitch tracker. In fact, the two were developed at the same time. So Matthias developed PN at the same time as we worked on Tony as an application for a particular study that he was using PN for. So the pitch track that it shows you and that it can play back, the one that with the three sinusoidal partials, that's directly taken from PN. And then the notes themselves, the blue rectangles, they are simply, I think, simply the median value of the pitch track within the time span covered by the note. The segmentation into notes is done by PN as well, and that's based on some state model which establishes the likelihood that a certain pitch is part of this note or part of the next, but obviously it's not guaranteed to be correct. In Tony, you can correct the start and end times of the notes, and it will then repitch the note, but again, just to the median of the underlying pitches. The reason for using the median, I think, was essentially to avoid getting into the question of how you determine the perceived pitch of a note which has a series of fundamental frequencies in it. So the pitch track is the fundamental frequency as deduced by PN, and then perceptually speaking, there could be a pitch that you hear associated with that, but Tony doesn't want to get into the program doesn't want to get into the question of how you figure out what the perceived pitch actually is. So it just shows you an indicative median value, and there's nothing more sophisticated going on to it than that. So it doesn't help. I'm afraid it doesn't help solve your problem of what the actual sung pitch is intended to be, if there is an intention that can be tied down to a particular note in that way. Mm-hmm. There's one other thing I wanted to just mention. You mentioned a utility for converting between frequency and between hertz and cents or MIDI pitch. There is such a thing in Sonic Visualiser already. It's on if you go to the view menu and say show unit converter, it's got a little converter that can do frequency to pitch for you. So view menu, and then down at the bottom, show unit converter.
Thank you. Thank you. This is great. And by the way, for those who have not used Sonic Visualiser, you can also, there's a nice nice measuring tool that you can take. So if there is a certain pitch, let me see which one. This was the third scale degree. So you could take the bottom, measure this between the bottom and the top, especially when you zoom in a little bit, and then if you hover the mouse over it, shows you the range. And I've used this as well to determine which values I want to use, but I need to zoom in a little bit more to do this accurately. But yeah, thank you for pointing that out, the frequency to pitch converter. Thank you.
Are there any other suggestions for Nico? Of course, I would have one or two, which is basically the same method as Chris mentioned, but it allows you to export the pitch values per hop, FFT hop, and then you could decide which one to take, right? Did you work with a pitch tracker in Sonic Visualiser already, the PN we just talked about?
Not really, no.
Let me show you. It's really cool. I really love it because it's pretty good and it's pretty fast. I hope my sound will work. This one is I think the third sample of your flute recordings in a spectrogram. Let's just listen to it really quick. Yeah, you know this one. So, and the first thing we could do is just to find out what's the basic pitch. There's this one very simple plugin. It's called Tuning by Matthias Mauch, and you press the K, and then it shows you on the left side the average. I guess it's probably a median value for the A. The concert A, right? So here we have 442 hertz, and then you go and press or select the P in a smooth pitch track, and it's pretty quick. You'll see the pitch track here. It's not very good with this specific sample, I guess, because the quality of the recording is not as good. The PN needs the overtones to calculate the pitches. But let's see, it's a little bit better here. You could even evaluate how good it works in toggling the playback of the pitch track, and then it sounds like this. That's awful, but it helps a lot to find out how good it worked, and then kick out all the values which are of no use for you. And then you just go and export the whole data set, and then you'll have this typical two rows, two column CSV output, right? And then just choose which pitches are of interest for you. For instance, the beginning of the note or the end of the note, you know? And with by help of the median pitch, you could just, by using Excel or something, relate that to an equal temperate scale or something. That was just
excellent. Thank you. Fantastic. I will try that today. Any other questions or suggestions? Well, that is okay too. And you want to go for dinner probably. Here it's not even lunchtime, but
I was going to quickly ask, just from like a more musicological perspective, what kind of direction you think about going in? What meaning are you hoping to extract from thinking of ascertaining these different pitches and the various different pitches, or are you still just thinking about using methods and investigating where that goes, or what direction do you see yourself going with this?
Well, in this case, in the psychoacoustic reaction, but how performers do this. I mean, there's obviously, in this case, it's singing, though there's a feedback, I'm sure. He listens to a pitch and then he adjusts it of whatever comes out of his voice, and instrumentalists would do the same. I do want to look at some blues that are played with other instruments that where the tuning is not fixed, or like non-fretted string instruments or something where you have adjustable pitches. But I do want to look at a lot more blues and jazz, and I would love to generalize this more eventually. But the main initial question was, how low is the blue note actually lowered? And that was a little bit surprising, at least with that third scale degree, that it's actually lower than more than a half step lowered. But then again, the data is very limited. But I wanna see that more, and then other pieces and other instruments.
Thank you. There's an remark by Axel Berndt.
Yeah, right. Probably not so much practical, but maybe it's nonetheless a direction where you could look for something. Audio transcription is still a topic in music information retrieval. And if you look at the ISMIR conference, you can every year find also new papers in this direction. These days, usually they do it with deep learning, and The problem there, and that's because it's not so much practical for you now directly, is that most of these things that they present there are not really available in a comfortable user interface, so to say. But it's yeah, research prototypes. But maybe you can find some promising works there and contact the authors and get these tools from them.
Yes, thank you very much. And yes, I have been looking into that. And yes, I have had problems with software that does not have a good interface or no interface at all, because at some point in my career, in my early years, and I started as a high school student really in the mid 80s to start programming, and then throughout the 90s, and at some point I decided not to do this anymore. And those programming languages that we used from the late 80s to the late 90s, nobody does them anymore. So and I decided my time is better spent on using other software instead of programming myself. But yes, thank you for that comment and suggestion. Anything else?
I'd just like to add this the idea of studying this would be of pretty much interest for classical music as well, I guess. I mean, you yourself mentioned it, and no violinist I know would say I love to play an equal tempered scale, right? We have this famous violinist Rudolf Kolisch, who said we have to. He was very polemic about it, but to my knowledge, nobody except him really made it this way. So it would be an interesting investigation how expressive intonation in classical music developed over time, for instance, on certain notes, let's say. I don't know the word in English. It's Vorhalt on what is that?
Grace note.
Grace notes, right?
Applicatura or something like that.
Mm-hmm.
Right, and yes, that's all very interesting. And yeah, so the project that I mentioned that was a failure was because I used a solo violin recordings. And in violin, I mean, different violinists do different vibrato, but they always have some vibrato. And so then the question is exactly how you measure it. And some recordings have so much vibrato that the range is so big in terms of pitch that there was not really a good telling of doing that. But at that time I didn't use Tony, and I didn't the PY that plugin, and so I could probably redo that and look at the results with those median values that Tony produces. So I might try that again. But yeah, those are interesting to me, those kinds of questions. Well, thank you again. And sorry for being selfish, wanting your feedback and suggestions.
I think that's one essential benefit of this kind of format, right? So, yes, if there are no other remarks, questions, so let's go to the evening. Yeah, there is Sauri.
Yeah, thank you very much for the interesting talk, and also this kind of discussions opportunity. I thought that it's only some kind of my thinking. I mean, it's the of course, this is blue notes also, or maybe that it's kind of relation to the blue notes, but you know, if you imagine the jazz or the blues music, then sometimes they don't hit the real notes, you know. Sometimes they do some kind of glissando thing, small glissando, and maybe it's also interesting to search about that. Then you can, you know, so to say, characterize the jazz elements or the blues elements, and it's of course is different from the classical one, I thought.
Yes, thank you very much. And I think to consider those kind of motions sliding onto or off a note need to be considered and can help with analyzing certain features in blues, jazz, and even in classical music. And I know that I think at the other workshop 2 years ago, we had some vocal music, analyzing vocal music to the approach and also the sliding off that was part of this. So I know it's being done, and that would be very useful in this context as well. Yes, thank you.
I don't want to do too much advertising for our presentation tomorrow, but we just developed a plugin which is able to recognize these kind of glidings, so portamentos actually, and there's one output who gives you the amount of the tone only which is not glided. So that could be a potential starting point for median calculations, so they won't be screwed by these kind of glidings. But I agree, Saori, that this is a rather theoretical consideration, which probably has to be beforehand, this kind of intonation measurements. I was thinking the same thing. What is deciding for us to hear blue note? Is it the portamento, the starting tone? Is it the end tone? Is it the average tone? You probably also need some psychoacoustical studies for that, or just determine it. I don't know. It's an interesting discussion, I guess.
Yes, and thank you. And I don't think I will be there that early in the morning tomorrow, but I was at your guest lecture that Julian hosted a couple of weeks ago, and I was so happy to see that. And I started experimenting with your Chris and your new plugin. And I think that has a lot of potential. That is great to see.
Thank you. Okay, dear Julian, dear Thomas, would you like to add something organizational?
Well, at first I have to apologize. I never toggled into these pitch measurements, and therefore I don't have any clever advice, but got some from you. So it's just the other way around. The only thing I can mention is that maybe one really should look into ethnomusicology here, because obviously in Indian ragas there's a lot with pitch intonation, and maybe they have some clever tools already developed to find out about this and have some more bigger samples, corpus studies, and maybe there's something to find. But just thanks again for listening to your presentation, because I learned a lot of it. So
thank you so much.
Thomas, sorry. Okay, so I'd say we had a packed day. Thank you so much for all these highly interesting presentations and the discussions. We're really excited for tomorrow. It will start at 10, and have a nice evening.